Hi everyone, welcome back to PardesLine. Today we are going to see together how to compute a bounding box of a mesh, of a bunny mesh, both aligned bounding box and also oriented bounding box, and how to convert a mesh to volume and how to perform some processing on the volume, such as erosion, binary erosion. Let's share my screen. We continue working on Visual Studio Code on debug mode. So let's import Open3D as a 3D, NumPy as NP. Let's also adding CPy for the computing binary erosion, generic binary structure, function which is a custom module, which I saved over there, a visual binary volume, and Loguru, it's another package to print some comment or also alarm in more professional way. So let's use it, as you can see here with info and the hour exactly of the printable thing. So we load the bunny mesh and we compute vertex normal for better rendering. We now compute the scaling just to make normalization of the mesh to get 1 unit for X, Y, and Z axis. We perform the mesh scaling. So let's visualize that as usual in 3D. Okay, so this is our bunny mesh from the Open3D dataset. Let's now computing the bounding box. So we have this option, Open3D, to get axis aligned bounding box and also get oriented bounding box. So we need to understand when we talk about the mesh, we have the global frame of the world. So get axis aligned bounding box, meaning in the global frame, we just take the bounding box aligned to the global frame from the object. And get oriented bounding box, it's more aligned to the local frame of the object. We assign a color to the axis align and to oriented bounding box. We compute the minimum, the maximum of the bounding box as you can see, because we already performed the scaling. So it should be 1 unit. So minus 0.4, minus 0.3, minus 0.4, and the maximum is about 0.5, 0.6, and 0.3. So we have around 1 unit per axis. So this is the mesh, original mesh with the axis aligned bounding box to the global frame. And now I also can display the local frame. So you can see the oriented aligned. We can get the same kind of bounding box using PC algorithm to compute the local frame axis. Let's continue. So now if we want to convert the mesh to volume, I need to, you remember the axis aligned bounding box in red. So this axis aligned bounding box, this one, okay. Let's imagine this one. I want now to divide it, every axis to a grid. So I need to choose a voxel size, and this voxel size will be my base to divide each axis. And so instead of being pixel like in 2D, it will be voxel in 3 dimension. Okay. So now I choose to use 0.01, and we will compute exactly the dimension. So let's first visualize it. So as you can see, instead of being meshes, triangle meshes, or being point for point cloud, this is now voxels. So cube for every voxel. Now I want you to see, like, currently, I just display the voxels of the object, but to compute the volume, we need to have the full grid. So remember the bounding box. So I want to fill it in voxels in yellow, and then inside we will see the bunny with other color of voxels. So to do that, I need to have the dimensions. So the dimensions, it's about the number of voxels, okay? And I just need to fill these dimensions with the center meaning center of each voxel. So I just create a list and append each point for each center of each voxel in the full bounding box, okay? And then get the grid points. And after getting the grid point in NumPy, I just converted to a point cloud from Open3D and assigned a yellow color to every single points, and then visualize the grid points with the yellow colors, with the voxel grid, which is the volume of the bunny in black. and we can visualize it, and also with the aligned bounding box. So let's visualize it right now. Okay, great. So this is my bounding box with point cloud, or it can be also called voxels volume, okay, in 0.01 as a voxel size. And inside, we can recognize the shape of the bunny mesh, and we can also recognize that is also volume, as we can see, the cube, okay? Let's continue. Now I want to convert voxel grid to binary volume. So instead of having numbers, I want to have true and false. So to do that, I just need to compute the mean and the max IDX, then to have the np.0. So let's see what is the volume here. Okay, so we have the volumes. Okay, only false, because currently I still need to assign true values to the bunny voxels. As you can see, the maximum, the minimum are set to false. Then when I use the voxels from the grid, from the original bunny, now I change that to true, and I can also compute the size. Okay, so the np.size of the volume. Okay, this is the full mesh I can have. The sum of that is providing currently the number of true. So I have 34 thousands of points of voxels true set in the around 100 thousands of voxels. Okay, and if I want also to have the dimension, so I can do volume dot shape because it's an numpy, so I can see my voxels dimensions. Let's adding a padding. So a padding also in convolutional neural network, padding is also well known. So when we have an image in 2D, we want sometimes to add a padding. Okay, what is a padding? Is like a pixel in each extremity of axis of the image. So in our case, it's also one voxel in each axis. So let's imagine volume padded. It should be one on each axis in each extremity. So two voxels added to the volume shape. So let's volume padded dot shape. And so we can see two axes from 103 to 105 and so on. Two axes, two voxels added to the y-axis and two voxels added to the z-axis as well. So now we want to compute the generate binary structure. So the rank is the dimension. So we have 3 dimensions. Connectivity, it's meaning when I compute a binary structure, each voxels is linked to his neighbors. And when I have one neighbor which is not set to 1 but is set to false, it's set to 0. So then I want to reduce and to remove the only voxels which are currently set to true and to 1. So it will reduce, it will operate such as of scaling down, reduce my volume and also remove some complexity of my volume. So we are going to see in 3D, and I hope you will get it. So volume eroded equal to binary erosion from the volume padded after I added the padding. And the structure is equal to the struct, which I use one connectivity corresponding to cis connected, meaning the radius I discussed, I take one voxels and the cis neighbors voxels around to make this computation. After being that, I just display it, and we can see that I removed some voxels, and now I can see like a skeletization of my bunny mesh. So it's interesting. This operator is used in a lot of cases. We will see that in the channel in also more videos further. So that's it for today. Thank you for following with me. Please share the video and subscribe to the channel. In the next video, I will I will explain the fact of sign distance function, which is a tools in the also 3D processing. It's a great tool, so I'm going to explain that next video. So thank you and see you there.